Okay, hi guys, this is Unit 10, Trigonometry, is section 10.1. This is lesson number 2. So, before we start with the exercise, those pages are on files. I'm gonna show you a video, short video, how can you understand angle of depression, which is about this lesson, and angle of elevation. Okay, if you got any question, you can contact me on Remind or Teams. Okay, I'm gonna use this to show you angle of depression and angle of elevation. Okay, so we're gonna imagine you are this person right here, and you try to look at something from, why it could be this three right here. Okay, so your line of sight, right, is gonna be this. You're looking straight to this three right here. So your line of sight, you call like horizontal line, is gonna be this one, right? Okay, perfect. But what about if you try to look at an up? What about if you try to look at an up an airplane right here? So your line of sight is not gonna be straight anymore. So you're gonna look at an up. So this right here, this purple line is gonna be your line of sight. But you create an angle between the horizontal line and your new line of sight with the airplane, right? And when you looking above, so that's gonna form an angle of elevation. And what about if you're looking it down? What about if you're looking it down? If you're looking it down like this little dot, okay? So this is gonna be your line of sight right now. And between your horizontal line, right, and your line of sight looking it down, it forms an angle of depression. But you see that is if you're looking below, right, is form an angle of depression. Okay, so I got this right here. So line of sight above the horizontal line is angle of elevation. Line of sight below the horizontal line is angle of depression. This is an example 1. A Power Ranger whose eye level is 5 feet above the ground measures the angle of elevation to the top of an eruption of a geyser to be 34.6 degrees. If the ranger is standing 200 feet from the geyser base, what is the height of the eruption to the nearest foot? We get here, the first thing we have to do is step number 1. We have to draw and label a diagram. So this is right here is a Power Ranger. It's 5 feet for the ground. So look at this is the line of sight. So this is my horizontal line. Okay. So it's 34.6 and 200 feet is the distance between the Power Ranger and the geyser. So we have to first get this height right here. So step number 2, we have to get x. So determine the value of x. So if you look at it right here, this side is across my right angle, so it's hypotenuse. This is opposite side, adjacent side. So to get my x, we're going to use tangent of theta is equal to opposite side over adjacent side. And then my tangent, we're going to substitute 34.6. That's my angle. And then I got the opposite is x over 200. I have to solve for x. So I'm gonna put both sides of my equation 200. I simplify on the right side. And then I got 200 times tangent of 34.6 equal to x. I'll multiply 200, right? Use your calculator. So you can use your phone also as calculator. So when I multiply this, I got 137.9, okay? So I'm gonna round to the nearest one is 138. So I got this height right here is x. So my step number 3, okay? So we have to determine the orbital. So all the height, okay? So we have to get the height from the ground until right here, okay? So how can I do that? So first, we got the x. This right here is 138, okay? So to get all this, we're gonna just add it, this right here, which is 5 feet, okay? So you're gonna add it this high. So it's gonna be x equal to 138 plus 5. So that is 143, okay? So that's the height of the direction to the nearest foot. So reciprocal 3 functions. So as we see in the lesson 1 on section 10.1, the basic 3 function is sine, cosine, and tangent. So the reciprocal is cosecant, secant, and cotangent, okay? So this is reciprocal to sine, cosecant, secant is reciprocal to cosine, and cotangent is reciprocal to tangent, okay? So every time that you see in a problem, they say that you have to find the 3 functions or find the value for the reciprocal is going to be this, just this. If you see the problem say the 3 function, so it's sine, cosine, tangent, cosecant, secant, and cotangent, okay? Alright, so this is exercise section 10.1, number 8 to 9. You got this information onto your files and teams, okay? This is number 8. You can check the exercise. They're just 2 pages, okay? So we got this problem right here. We got the data that we got is 22 feet the height. We're talking about escalator and I'm almost lift customer to a height of 22 feet. If the angle between the escalator stairs and the ground floor will be a 30 degree, what will be the line of the escalator? Okay, so first, remember, step 1, we have to draw and label a diagram. Okay, so we got this triangle right here. We got the 1, we got the 22, we got 30, that's our degree. So we got opposite and hypotenuse. So what is that? That's sine of theta. So we got 30 degrees sine of theta is going to be equal to 22 over L. So we're going to represent the L as my length, okay? So, if you look at this right here, you can see this is in a special triangle. And why is that? Because we got one angle is 30. We got the right angle, right? So it's 90. So we got 30, 90, and this is 60. That's a special triangle. So if you look in the chart, I send you those pictures for lesson 1, section 10.1 as on Teams. So you can look at the sine of 30 is equal to 1.5. So we're going to substitute the 1.5 right here, okay? So I have to solve for x. I'll multiply both sides by 2, right? So then I have to multiply by L both sides of my equation. I simplify, and I get L equal to 44, okay? So why not use this chart? Because this is, I remember you, this is 90, so this is 60. And why is that? Because the sum of all the angles inside the triangle is equal to 180, okay? Okay, so exercise number 9. The pilot of a hot air balloon measures the angle of depression to a landing spot to be 20.5 degrees. If the balloon's altitude is 19 meters, what is the horizontal distance between the balloon and the landing spot? So step 1, remember, I'm gonna draw and label a diagram. So I try to do the best I can. Okay, so I'm drawing right now my diagram. So this is my set number 1. I have to represent the B as my volume. So is this right here, and I got L is along this spot. Okay, L is gonna represent my landing spot. Okay, so I got the angle of depression to a landing spot is 20.5 degrees. So it's a landing, this is an angle of depression, okay? So this is we're just gonna imagine this is the person inside my hot air balloon is looking it down, so it's an angle of depression, right? And because of that, this angle right here reflects, okay? And this, right, so it's and this side right here, okay? So this is my height. My altitude is 90 meters. So I got this, which is my opposite side, and I got this, my agency side. So we have to find x, okay? We have to find x because they tell me what is the horizontal distance between the balloon and the landing spot, okay? So this distance right here is x. So tangent for theta is opposite side over agency side. So I got tangent of 20.5 equal to 90 over x, okay? So I'm gonna solve for x, okay? I'm gonna solve for x. So it's gonna be 90 over tangent of theta, tangent of 20.5, right? So I divide this 2, and this is gonna be 241. So I round that amount to get 241. So well guys, this is all about that you need to know to work on the exercise in section 10.1. So you're gonna find form into teams to work on that, okay? So I'm gonna send you also this note as a notebook, section 10.1 lesson 2. You don't have to write down the notes, but you have to solve the exercise, and you're gonna post an assignment as an assignment tab, okay? So you have to work on that assignment. So have a great week. If you got any questions, you can contact Reminds our team. Take care.